Hi, so this is my second paper, and now I'm going to talk about using component ensembles for modeling autonomic components collaboration in smart farming. In this speech, I will discuss how authors of this scientific paper structure the International Symposium on Software Engineering for Adaptive and Self-Managing Systems. So this system currently facing a lot of problems, and the first one is the situation-dependent collaboration facilitated autonomic ensembles that optimize operation when operation is non-controllable environment situation. So in smart farming, agricultural machinery and equipment monitor their operation characteristics and job characters, whereby the data is uploaded to cloud servers for future references. The implementation of smart systems in farming facility higher efficiency and minimizing farming costs since these systems operate autonomously. Therefore, the author of this paper cooperating autonomic system components under the trait-based components ensemble topology. As I mentioned before, there is quite a reason still the problem still existing, and it is because intelligent system is increasingly being utilized in consequently autonomous farming. The technology is shifting from isolated adaptive components to larger self-synchronizing systems that boost reliability while minimizing the running cost. A farm civilian system consisting of team of unnamed autonomously drone is taken with monitoring farm crops by scaring of birds. Since drones run on limited battery charge and the charger can serve only 3 devices simultaneously, the problem has to determine the adequate number of drones required for efficient surveillance of the entire farm, while assigning the task of scaring birds to closest one with sufficient energy. There is quite a lot of scholars who did similar work. The scholar learned how ensemble constraints of algorithms for a given function and their respective implementation components from the code implementation and ensemble line assembly. Although the running code utilized in this source from the open source as a setup allow investigation of Scala setup under ORCA agent framework for constructing the SL platform for ensembles framework. While writing the scientific paper, the scholars learned about the ensemble baseline implementation and the coordinate components for efficient and stable operation of system. However, the placement of drone on field was not optimum since the researcher didn't account for a randomness factor. For instance, unless the field is attacked by bird, flock, or need of charge, the drone system assumes a near optimal formation which constructs the dynamic requirements of autonomic monitoring system. So the main idea of the system is to run various components including drones, charging stations, and birds. Those are modeled as components coded in terms of ensembles, time-bound space, and time. In autonomous systems, components perform multiple actions in updating their knowledge about their unknown environment statistically, while actions are determined dynamically. The semantics of the nesting process ensure that the parent ensembles are defined on overall goal subsection, thus ensure that the system works as entire process. Using a Scala-based domain, the author creates domain-specific language platforms that facilitate rapid development. However, the DSL domain demands the specification of runtime CSP process in programming knowledge for Chocosolve class solver. For DSL adopted by authors, all the system components and their respective ensembles are modeled via classes that instantiate multiple times. So, which means the drum, the charger, field, and the bird flock components for the system. Due to the dynamic aspect of these components, their respective information is updated through class field, although the field and bird flock components are uncontrollable in entities. Therefore, while the field component is statistically initialed, the flock component is dynamic aspect and is dynamically instantiated as per detected bird flocks. Under this schedule, the system configuration yields 6 assembled types, including drum protection system and 5 nested system hierarchies. So, does this system work better? So firstly is the top-level ensemble classes drawn either as ready for action or need for charging. The determination of drawn state is based on components currently mode and its respective energy level. The static field position is determined from thread length since dimensions and area size of the field doesn't change state actively. The number and type of bird flock on the field constitute the dynamic component, and their information is updated periodically according to component change. Since the unnamed aerial vehicles are tasked with scaring of birds, the scare formation identity farm region infested by large bird flocks. It adjusts their target coordinate locations for bird scaring. Depends on their current location, the unknown patrol ensemble lays down the direct route for drones towards the unknown location. In construct, the charge ensemble institutes the protocol for assign task of scaring function dedicated to drone with sufficient energy to fulfill the task. The principal ensemble function will then instantiate the priority of the drone assignment depending on the threat level. For instance, if there is a field section under attack by birds, the task is assigned the higher priority, while monitoring tasks are assigned to lower designation. So in this article, the author provided an autonomously composable and context-dependent approach of developing autonomous collaboration and the demonstration of a smart agriculture method. An integrated Scala-based DSL was created to define collaboration structure, and a framework is assessing dynamically grouped during the runtime, and the execution is fully accessible and ready to future experimentation. So as for the critique as a task for near future, the researcher aimed to improve the modeling aspects to solving ensemble collaboration, expanding on DSL plate capacity. And this essay didn't really solve the problem of the drone energy supplier, as the drone usually can only run about 20 minutes and need to charge it for more than that time, which is a problem. And thanks for listening.